Hi guys, and in this video we're going to look at Unit 3 in Pentask 5. So you'll notice we took away the topics, mainly because as you know, for the exam you're going to need, this is going to be a really important skill for you to have, is be able to identify what topic it is, okay, and then apply the correct skill accordingly, okay. So we'll quickly run through what the topics were. So topic 1 was equivalent form. Using the trig, okay. Number 2 was trig identities. Number 3 was differentiation. And number 4 was your modulus function. And then number 5 was your inverse function. So you should have completed those questions now. And then you should have also made a note of the level of support you used. So just remind yourself, if you're not using anything, that's really good. Just keep it ticking away in the background. If you get into level 1 and level 2, that's a topic that requires a small amount of action. Okay, maybe a few quick reminder, a couple more past paper questions. And then level 3 and level 4, you're looking at a topic that requires yourself a lot of work, okay? So let's run through each one. So first we've got our equivalent form. So express, so I've got cos theta plus 2 sine theta. And I want to express it in the form of this. So what I'm going to do straight away, and write this as my double angle formula, okay? Or my additional formula. So I've got R, cos is cos, then cos, sine, sine. So cos theta, cos alpha. And it's always the opposite sign in the middle. So my negative there, so it's a plus here. So R and then cos, sine theta, sine alpha. Okay, that's the first thing I do. Now I can find R straight away by using some Pythagoras. Okay, so the coefficients here are 1 and 2. So I'm going to do 1 squared plus 2 squared, which gives me root 5. Now I'm going to leave it as root 5. I don't want to deal with that nasty decimal. Root 5 is far more accurate for me to deal with. Okay, the next thing for me to do is to equate my coefficients. So I've got cos theta on this left-hand side, and that's 1, my coefficient. On this right-hand side, I've got R cos alpha on my other two terms. Then I've got the sine theta, which is 2. On the other side, I'm going to get R sine alpha like so. So I've got equation 1 and equation 2. I know I'm going to try and make tan because I've got a cos and a theta there. So a cos and a sine. So I'm going to do 2 divided by 1 because I know that that's sine divided by cos. So that's 2 over 1 is sine over cos. Okay, now the whole point of this is so my r's cancel, so I can get rid of them. I've got 2 now on this side. Sine over cos is tan, so I can solve that for my alpha. Now be careful, it's in radians, so you've got to make sure your calculator's in radians. Okay, little things like that we've got to be careful for. Okay, normally these questions are in degrees, but in this case it was in radians. So you've just got to be careful about making sure we switch those things around. Okay. So now I know my 2 parts. I'm going to put back into the equation. So I've got cos theta. So therefore, cos theta plus 2 sine theta is going to be R, which is root 5, cos of theta minus 1.107. Okay, so there's my final equivalent form. Now this is the part 2. This one's a little bit different. So I've got the function is defined by f of theta and it's given this. So you can see I've got the initial parts. So I've got cos theta plus 2 sine theta on the denominator, but I've also got this plus k. And that's true for between 0 and 2 pi. That's fine. And then k is a constant. They're telling me the maximum value of this is 3 plus root 5 over 4. I need to find the value of k. So straight away, what I'm going to do is I'm going to rewrite this with my new equivalent form in it first. So part B, that's the first thing I'm going to do. So I've got 1 over, and I've got k plus, and then I've got root 5 cos theta minus 1.107. Write that a little bit better. Okay, that's me rewriting it. Now, I'm talking about the maximum of this, okay? So this fraction is the maximum when the denominator is the minimum, so as small as it possibly can. So I'm going to make this as small as I can. Now I'm looking at the cos, and I know that goes between 1 and -1. So I'm going to make it -1. If I do that, I get k minus 5, minus root 5 on the bottom. Now they're telling me the minimum equals this. Okay, so I'm going to rearrange and solve. So I'm going to do some cross multiply. I'm going to 4 up. Okay, I'm going to actually go down to the next page. So I'm going to the 4 up. I'm going to bring I've got my 3 plus root 5 over here. And I'm going to times that by k minus root 5. Okay, I'm doing some expanding and solving now. So I've got 3k minus 3 root 5 plus k root 5 minus 5. So that's what I've got. I'm going to collect my things with k in them. So that is the 3 and the root 5. Then I'm left with minus 3 root 5 minus 5. And I'm going to solve. So I'm going to take these two points over here to the other side. So I'm going to add them on. I'm going to divide by my brackets. But I end up with k being exactly 3. Okay, so slightly different because it wasn't asking you for the maximum or minimum. Okay, it was telling you what the maximum and minimum was, and you had to solve it from there. Okay, whenever you get those kind of questions, think you're going to have sine and cos, and you know that those go between -1 and 1. So which version do you want to use to make your answer either as small as possible or as big as possible? Okay, so question 2, we got trig identities. Okay, now we solved these in the exact same way you would have used last year. We just got different identities to use. So I've got 8 tan, first of all, between 0 and 360. So again, make sure we're in degrees this time. 8 tan squared theta minus 5 sec squared theta equals 7 plus 4 sec theta. Now, I've got an equation. I've got sec squared is 1 plus tan squared. And I've got to somehow use this. Now, I've got tan squared to sec squared, so those two I need to get rid of, but I've got a sec theta, which I can't change. So that tells me I need to make everything sec. So I need to get rid of the tan. So I'm going to rearrange this equation. So I've got tan squared is sec squared minus 1. And I'm going to plug that in. So I've got 8, and then I've got sec squared theta minus 1 minus 5 sec squared theta is 7 plus 4 sec theta. Okay, I'm going to span and solve them here. So let me expand this single bracket first. And we've clearly got a quadratic form in here. So I'm going to take everything over to the left, and I end up with minus 4 and I'm going to factorize and solve. Now you've got to make sure you are actually showing this factorizing thing. I know lots of us tend to go straight to our calculator, but you need to make sure you show this line in between. Okay, this can be worth a mark, so it's important that you do so. Okay, so that means sec theta must be minus 5 over 3, or sec theta must be minus 3. Sorry, positive 3, not minus 3. Right, sec is 1 over cos, so I can flip the fraction on the other side, gives me minus 3 over 5, and this one's going to give me cos of a third. Okay, nice and quick to change those over, and I can solve them each. Okay, this first one, the first number it gives me is 126.87. I'm going to use the cos graph here to help me find my other values. It's a really rubbish sketch, but we understand how to use that now. And then my other value is 233.13. And then the other version, if I do inverse cos of a third, I get 70.53. And then my other value is going to be 289.47. Okay, so there's my 4 values I get out from that. And when we get to this end bit down here, it's the exact same as we did last year. Find one, think about what range you're looking at in between, draw your graph, try and find your other corresponding values. Okay, number 3, got some differentiation. So I've got to differentiate each of the following. So part 1, straight away I see this. So I've got the 4th root of 9 minus 4x to the 5. And I'm going to straight away rewrite it in terms of indices. So that is 9 minus 4x to the 5. And it's a quarter because it's the 4th root and a negative because it's on the bottom. Okay, that's going to allow me to find dy by dx really quickly now. So I'm going to do chain rule here. Bring the power down. And I'm going to leave the bracket alone. And I'm going to decrease the power by 1. So it becomes 5 over 4 now. And I'm going to times by, and I'm going to differentiate the bracket. So if I differentiate the bracket, I get minus 20x to the 4. And I'm going to tidy it up a little bit. Okay, so I've got minus a quarter times by this is going to give me positive 5. And I've got the bracket that I can't do anything with, so I'm going to leave it as it is. Okay, number 2, I've got a fraction. Now, I know the first one we had a fraction, but I didn't have a function on the numerator. Okay, this time I've got a function on the numerator and the denominator. Okay, so that's leading me to use quotient rule. So u is going to equal the top, v is going to equal the bottom, and I'm going to differentiate them separately. So du by dx. So the first one, I'm going to end up with 6x squared. I'm going to do dv by dx as well. It's going to be minus 3x squared. So I can now use my quotient rule, which is in the front page of our form booklet. So the first two have to be these two. So v du dx, so 7 minus x cubed times by 6x squared. Take away the other two times each other, so I got minus 3x squared times by, I'm going to put some brackets around these so we can see where they've come from, times by my 3 plus 2x cubed. And all of that should be over v squared, so 7 minus x cubed all squared. Okay, now don't expand the denominator because most of the time you can simplify things out. So I'm going to take my time now. I'm going to tidy up that numerator a little bit. Okay, it does say to simplify the answer whenever possible, which I did for the first one, and I need to make sure I do now. Okay, so I'm going to expand those brackets. So I end up with 42x squared minus 6x cubed plus, because I've got two negatives, 9x squared, and then plus 6x to the power of 5. So it'd be 6x to the power of 5 here as well. Okay, you'll notice my numerator simplifies a little bit more, so I need to keep going. And I end up with 51x squared all over 7 minus x cubed over 2 squared, sorry. Okay, these two cancel each other out, equal and opposites. I'm left with that. Okay, so there is a part B to this, and it's about the inverse sine. Okay, so sketch the graph first of all. Now this is one that we just need to remember. I need to know. So I need to sketch what this looks like. So I'm going to draw my axes. Okay, and it's going to go a little bit like this. Okay, where it's between 1 and minus 1, because that's what we're used to going between in the y-axis, but the other way around, then pi by 2 and minus pi by 2. Okay, so that's just a graph we need to remember and learn. Now the next bit, it tells me to rewrite this as x equals sine y. And it wants me to differentiate it, okay? And again, if you read the question again, find dy by dx in terms of x. you need to justify any choices that you make. So the first thing I'm going to do is I'm going to do dx by dy. Okay, sine goes to cos, so I get cos of y. Nice and straightforward to start with. Now I can flip that to find dy by dx. So I've got 1 over cos. Now the issue is that's in terms of y, I need it in terms of x. So to get in terms of x, I'm going to use sine squared plus cos squared is 1. Okay, and if I rearrange that to find cos, I get 1 minus sine squared and then all rooted. Okay, so if I put that into my dy by dx, I've got 1 over. Now I know what sine y is. It's x, so I've got 1 over the root of 1 minus x squared. Okay, now that is the formula that we get in the booklet as well, so we know what our target is. So if you aren't getting the target, we know something's gone wrong. So for question 4, we've got some modulus functions. Now the sketching one's a little bit harder with this one than they may be used to. Okay, so we'll have a look at it in detail. I sketched a graph for y equals x squared minus 4 and y equals the modulus of x squared minus 4. Indicate where the points meet the x-axis and the y-axis. So first of all, let's draw the first function. Okay, let's draw two separate graphs. It doesn't say on the same graph paper, so I don't need to worry about that. Okay, so for the first function, okay, it's going to cross the y-axis at -4, and it's going to be symmetrical like so. Okay, it would cross the x-axis at 2 and -2, so that is my graph there. So for the second one, I'm going to use that to help me. Okay, my curve is still going to come down and touch it at 2, and still going to come down and touch it at -2. Okay, however, as we know, where the modulus, as it hits the x-axis, and put my x and y-axis on, almost bounces back up. So instead of making this U down, it's going to make this kind of shape back up. Okay, now it's symmetrical. So if it hit -4 down here, it's going to hit +4 up here. Okay, so bounce back up from that x-axis. Okay, so there's my two graphs. That would be y equals the mods of x squared minus 4. Part B, a nice solving question. Okay, so I'm going to go down to the next page so I have enough space. So I've got mod of 5x minus 3 is greater than 4. So the first one is I'm going to leave it alone. The second one, I'm going to flip the inequality and flip the sign. I'm going to solve them both separately. So we've got 5x is greater than 7. So x must be greater than 7 over 5. And here I get 5x is less than -1. So x must be less than -1/5. Now, can I put them together? No. So I'm going to put, therefore, x is less than -1/5, or x is greater than 7 over 5. Okay, I can't put them together. I need to leave them as separate. So the final question, something like this has come up in the past, okay, and it throws a few people off. So I've got a quadratic here, and you'll notice in part B I want the inverse. Now, to do the inverse, it has to be a one-to-one function, okay, which currently it is because of the domain. They've restricted the domain, which makes it a one-to-one function. So for part A, it wants it in this format, which is completing the square. Okay, so if I've got my function, so if I've got f of x is x squared minus 8x plus 7, I'm going to do my complete the square. So obviously this is a last year kind of skill, but we still need to remember it. So I've got x, I half the coefficient here, so -4. I take away the square of that, so -16, and then I leave the plus 7 on the outside. Okay, I'm just going to tidy it up. So x -4 squared, and then -9. There's my completing the square. Now, part B, it wants me to find the inverse. Now, I have to use completing the square here, so I'm going to do let y equal my x -4 squared minus 9. Okay, I'm going to rearrange it. So plus 9 to the other side. I'm going to square root it. Let's remember, when we do square root it, we get plus or minus. We'll decide which one we're going to use at the end. And then I'm going to have 4 plus or minus the root of y plus 9 is x. So now I need to decide which one I'm going to use. So am I going to use plus or minus? Because this isn't a one-to-one function at the moment. So the domain of f is minus infinity to 4. So that means the range of my inverse should be the same. So out of this function, I need to get 4 and less. So I need to make my number smaller, which means I'm going to take the negative from here. Okay, because if I did a positive, I'm going to keep adding numbers. Okay, and I actually want to make it smaller than 4. So if my 4 is my starting point, I'm going to add, or I'm going to want to add numbers, take away numbers to make it smaller. Okay, so therefore, f to the minus 1 of x is simply going to be 4 minus the root of y plus 9. Okay, so you need to decide which one you're going to do at the end, depending on what the range is. Okay, guys, so apart from that, make sure you've made a note of all the levels of support that you needed, and I will see you in the next video. So thank you, guys.